Hello, Ajeet. Hi, Ajeet. Are you able to hear me?
Yep,
How are you doing?
I'm doing good.
Awesome. We are really glad to have you, Ajeet, for our conference Open Source Software Days, and hope you are also pretty excited for the conference.
Yeah, thank you.
Awesome. So, Ajit, you are the first speaker for the conference. So, before that, I would request you to give a quick introduction about yourself. And meanwhile, you can also present your screen so that we can put it on the screen.
Yeah, sure. So let me get started with the slide. Can you see my slide
Awesome.
here?
Yes, yes. Yes, Ajit, you are live.
Okay, then I will go ahead with the presentation. So thank you, everyone. Thanks for joining today. I know that there has been a lot of crises related to pandemic, which is right now going on. But despite the fact that we are here to talk about new technology, to learn new things. So thanks to the organizer, the confab, and all those 30 plus, 40 plus, basically 40 plus community partners who have come together and organize such event. So today I am here to talk about a really interesting topic around real-time object detection and analytics using Docker and Redis Edge stack. So let us get started. So a little about myself. I am blogger at Collabnix. Collabnix is my personal website, which has today around 230 plus blogs on Docker, Kubernetes, and cloud. I am a part of a Docker Captains program. Docker Captains are those experts who go ahead, talk about the technology around Docker, Kubernetes, and especially cloud. And I have been Docker Captain since last 4 to 5 years, and I have been writing, conducting, organizing meetups, conferences all across the globe. I'm also I'm a developer relation manager at Redis Labs, and usually I go ahead and build a developer community and help them adopt Redis. I'm also Docker community leader. We have around 10,200 plus community members in Docker meetup community, and I, along with my fellow co-organizers, been organizing events like OSCON, Docker meetup, Docker Pune, and there are other 5 to 6 communities all across India. I'm also part of ARM Innovator. I work very closely with the ARM community team and try to grow the community in terms of blogging, as well as I'm working in one of the robotic platform called Cherrybot, which I am going to talk about maybe in my future, in the future events. I worked in the companies like Dell, VMware, and CGI in the past, and worked in a different role like IT consultant, QA engineer, as well as a principal engineer. Collabnix.com is my website where you can find all those exciting stuff which can help you to get started with Docker as well as know the latest tech and trends. So today agenda looks quite busy here. I have brought a really interesting topic which I started exploring around 3 to 4 months back, and this is all about AI as well as AI database. Uh, this is something which is quite new, and people have been really writing about that. So I just thought that whatever, based on the learning and experience which I have around it, I will go ahead and talk about it. I'm also going to talk about AI data pipeline, which is really important. There has been a lot of people who have been talking about AI, but you hear very less about AI data pipeline, which is really a kind of a fundamentals of AI pipeline itself, right? And then I'm going to talk about the challenges. What are the challenges with the AI serving platform today we have in an open source as well as an enterprise market? Why Redis and Redis AI? We'll see like how Redis as a NoSQL in-memory key value database, how it solves the problem of the inferencing here. And obviously, you can expect Docker always in my talk. So I'm going to show you like how I can go ahead and especially containerize the whole Redis Edge application, which solves the Redis AI inferencing problem altogether. The target audience for this complete presentation would be MLOps, Okay, just like a DevOps, which is basically a collaboration in between the developer and operation, we have MLOps, which is a collaboration between data scientist and basically the operations team. So if you are one of them, definitely you are going to benefit all of it. So let me start with the problem statement. The problem statement is, we have been talking a lot about AI. AI is AI, which you talk about, artificial intelligence. It is basically that branch of computer science which basically goes ahead and try to build those systems which behaves, or you build such kind of an intelligence into the system which behave very similar to how we behave today, right? And let me give you some of the examples. Think of it as like, if you are a Netflix user, the next time, say you finished watching one of the movie, and the next time when you go ahead and try to browse the movies, it recommends you something saying like, okay, this is like this is a movie which matches around 93% of what you like. That is basically an AI algorithm which goes in the backend. The one other example would be when you are doing a shopping in Amazon, right? When you are buying a product, and the next time when you order the product, it comes with some kind of a recommendation. That's an AI which is running in the backend. Another good example would be more to do with the LinkedIn. So you might have seen, like, most of the time when you receive a message saying, someone says, "Hi, how are you?" And then there is a kind of a recommendation engine which basically does a kind of smart reply recommendation. That is an AI, and it has something to do with the natural NLP, right? Natural language processing. So AI is everywhere. One of the best term to talk about the AI is the ubiquitous. They are like everywhere. But the problem is, when we talk about AI in production, and that's the problem. No one is talking about AI in production, and that's where the whole the challenges come into the picture. The hardest part of AI is not AI; it's basically a data, because now you have an enormous volume of data which is coming to the system. And now, to accommodate those volume of data, you need a very robust database, right, to go ahead store it. And as I talk through it, when you have an like a large accelerated growth of data in terms of volume, in terms of variety, and in terms of velocity, like, you need a system which can accommodate it. And why we are talking about that, the reason is, because of that, there is a kind of a special type of database which has emerged, which is called as the AI database. Now, AI database is basically targeted with a purpose of speeding up your machine learning as well as model serving. Now, these are two important components. In AI, it is basically a combination of ML and DL, right? So we are talking about a machine learning, and we are talking about the model serving, which comes under the deep learning. So how we can go ahead and speed up both of these stuffs, that is where the AI database come into the picture. And when we say data, we should know how to go ahead, how to explore the data, how to analyze it. So one of the problem which you would see when you have a huge amount of data is, there are certain types of data. One is a good data and one is a bad data, right? So when we say bad data, it could be some kind of a duplicated data which is coming into the system. And when you have a duplicated data in your database, then most probably whatever the report you produce, right, that might not be accurate. So the reason why we are concerned about the data is, if you when you look at the data pipeline, which I have in the next in the slide, you will realize that when the data moves from the data ingestion stage to to the AI serving phase, right, you will see that there are a lot of challenges in terms of uh, collecting the data, training the data, segregation the data, and then serving the model itself. AI database is a special type of database which helps you to better wrangle the volume, velocity, and complex data governance, and it meets all those the categories, all those requirements, which helps you to take AI model to the production environment. And definitely with open source, since this talk is more, and a whole conference is more about the open source, so whatever I'm going to talk about is related to the open source code, open source tools, open source model training, and the models, right? And when we say open source, it comes with the lower cost, but at the same time, it is robust. Now let us spend some time about the AI pipeline. And this is really important, because if you see, there are around 5 stages, starting with the data sources and then ending with the model serving. The problem at each of the step is it is very sensitive to data, and we will see in the consecutive in the subsequent slides. The first and the foremost thing is it is the data ingestion part itself. So you might have a data which is coming from IoT devices, for example, or few of the business processes, right? That data has to be ingested, and this data could be anything in terms of the sensor devices, or it could be anything like based on the fraud detection, right? One example could be, or product recommendation, right? There could be a product catalog, and then you have a product recommendation stage. And once this data which is received, it is basically in the raw format. Now, the raw format data has to be in one or multiple ways. It has to be classified and transformed. And in the diagram which you see, if you look a bit closer here, we are trying to go ahead and classify those data, and then put it in the kind of data preparation stage. In the data preparation is basically the pre-processing of your data. And once the pre-processing data is received, then that has to be trained, and that is where your model training come into the picture, where you have a deep learning framework which comes into the picture. So in one way, you have an old data, and now that old data, from that old data, you have to create a logic, and that logic will help will help you in inferencing part, where the machine will learn itself what to do. And that is the reason why you see all those recommendations which you coming in the Netflix system is intelligent enough to go ahead and respond, which means that whatever you have been doing today, your system or your robotic platform, those robotic platforms are able to understand that, and they are trying to behave in the same way. Now, for each of these stages, we have a characteristic. There are feature requirements. Look at the data sources. It is very sensitive to data variety as well as the volume. Data ingestion is very sensitive to data velocity, because there are a stream of data which is coming into the system. It has to go ahead and accommodate those data. Data preparation stage is very sensitive to data quality, because now when you have a raw data and you have to go ahead and classify them, right? That is where the data preparation phase comes. And then all about the throughput, caching, response time, data access latency are the sensitive things which basically the model training or model serving is inclined to. Now, if you look at the challenges which we see here, there are four of the topmost challenge which we face with the existing AI serving platform to take it to the production. The first is a slower end-to-end inferencing, right? Now, if you look at the diagram here, the time taken for collecting and processing the reference data is much more larger than the inferencing part. And that is where the inefficiency of the whole AI pipeline falls into the crisis, right? So where you have a data in terms of time series, key value, stream, columnar, graph, or it could be like a document or RDBMS, right? These are the ways where you collect the data. These are kind of a databases, right? So the time taken for collecting the data is much more than inferencing, and that makes, because inferencing is something where your trained model start to behave, you start to learn how you have taught that particular model, right? The other important factor here is, and inferencing is definitely it's one of the most challenging stuff which we have today. Even if you see the vendors like Nvidia, they have been coming up with a kind of AI platform like Jetson Nano. It solves the problem, but it doesn't solve like 100% of the problem. The problem of inferencing will still be there, because your data has to stay very closer to where your database is, or say your models are deployed. So right now your models or the inferencing might happen outside the database here. The other important thing when we talk about the production environment is a lack of HA, because now the data is very important. You don't want to lose the data altogether. At one point of time, if it doesn't go ahead and try to collect all the data and produce a result out of it or add a logic to it, it doesn't make sense. The other important fact is there are certain models, there are so many backends which are there. How you go ahead and choose those models? So your platform, it should be your the solution which you have been using, especially for the training as well as the inferencing, should be agnostic in nature. It should work in any of the platform. If I have a solution which works just on x86 hardware and not working in ARM platform, that doesn't make sense, because edge devices are where you collect all those and you want to do all the inferencing part too, right? And then the complexities today, if you see, even if you go ahead and try to compile a solution against the TensorRT or TensorFlow, it takes around 40 to 50 hours of time, right? So it should not be much complex. It should be easy in order to go ahead and deploy those models. Now, why we are talking about Redis here? Now, Redis is basically an in-memory key value NoSQL database system. In-memory means it works on RAM. Key value is the way how the data structure has been built in way you have a key and the value. And then the next thing is basically a kind of a NoSQL database, which means that your data can be in any other form, in the images, in terms of MP4 videos, or it could be in terms of blobs, storages, objects, and all. And you need to have a database which can store that. So Redis is a database which has all the three capabilities. It is an open source, so you can download it, you can install it on any of the Linux or Windows machine. Two of the really important things we really need to have to talk about is the latency and throughput. Low latency and high throughput is something which is really important, and which you get via Redis. And Redis has a data structure also, right? These are like the all open source data structure which you can go ahead and use. The third point is extensibility. Now this is where we extend Redis in terms of time series, in terms of artificial intelligence, in terms of JSON graph, in terms of serverless platform. And these are the modules which we are going to talk about today. When you say so let me go to the next slide here. So Redis AI is basically the extensibility which we are talking about. It is a kind of a Redis modules which is open source today. You can even go ahead and try out as a Docker container. You can see the command here, Redis AI /Redis AI. You just have to pull and you have to run it. Redis AI basically does what it does. It basically a module which provides you a tensor. Now, when you say tensor, it is a generalized format of scalar and vectors. So there are certain matrices. And what you can do today is you can load these particular tensors as a data type directly into the Redis. And that can be used with GPU, CPU on any of the platform, along with the backends like PyTorch, TensorFlow, and all. If you so what Redis AI does, it basically turns your Redis into a full-fledged deep learning model execution. Okay, it runs it comes with the promise of saying, like, you can run it even on your Jetson Nano board, or you can run it on your Raspberry Pi, given the condition that it has to use a CPU only. Okay, and then it supports all this data structure which is mentioned, like tensor model and script, as well as ML and backend, ML and DL backends like TensorFlow, PyTorch. So these are the leading backend which every solution is looking out for, because they are meant to take the AI to the production environment. Now, benefits of Redis AI has been more like you have a database, you have an in-memory database system, and your data itself, the tensor itself, live inside a database. So you don't have to have, say, the two separate entities sitting separate to each other. It is more like you have a deep learning platform itself inside Redis database, so which makes the inferencing quite faster, right? You can deploy new models. You can have 10x performance when you are dealing with it, and it has support for major AI backends. It runs everywhere. So this is really cool, and you should go ahead and try this out. Now let's talk about Redis Edge. When you say Redis Edge, it is basically a combination of Redis modules as well as Redis OSS. OSS is open source software. So we have a Redis open source version in combination with streams. Streams, you can think of it as like more like an Apache Kafka kind of a stuff, where you have a huge amount of data coming in and it will accommodate it, right? And then you have a modules. Think of time series as kind of a like a Prometheus, where you can go ahead and run a kind of a time series database. Redis AI is more like an Amazon recognition service, and Redis Gates is more like a AWS Lambda kind of a stuff. But the whole idea is, in order to go ahead and improve the inferencing, you don't have to really deal with any external entities. These are the modules which can be packaged in the Redis database itself, and you can run it. So basically, it bundles all those Redis stream, open source Redis, and Redis modules. And in one of the demo which I'm going to show you, I will show you, like, with just using one Docker Compose file, how I can build the complete solution with all those different components running as a microservices. And again, look at the footprint, like it is lesser than 5 MB, so it can easily reside in any of the constrained compute environment. It can run over the ARM based platform also. And especially, let's not forget about millions of writes per second, as well as the latency, because Redis claims that it is like we promise around less than 1 millisecond of latency, which matters a lot when we talk about any kind of a database. Now, if you look at the complete operation pipeline, this is how it looks like. So you basically get a kind of, think of it as like you have a Raspberry Pi which is connected to the camera module, or think of it as like a Jetson Nano board which is connected to the camera module. And those streams of data has been it goes to a kind of especially Redis stream, so which you see the second box here, that is a Redis stream. And the moment you get a frames, the moment you get a frames, it basically triggers your serverless function here, which is like Redis gears. And then after that, the Redis gears basically triggers, especially the Redis AI is something which is more like an Amazon recognition service, where you can go ahead and recognize the objects. Okay. And then it basically stores the tensors, and that is where it recognizes that the person, as a bottle as a bottle, right? It identifies the object. And once it collects all those data, it basically stores it in Redis time series, which is very similar to how you see a kind of Prometheus, because that is where your time series database come into the picture, and that gets display on the Grafana. Okay. This is how the whole operation pipeline works. And in the demo, I'm going to show you how to go ahead and implement all of these things. Now, we talked about everything. The only thing which is pending is why Docker containers. And the reason is, if you look at the recent report which has come from 451 research, right? They do the survey around AI and containers. They found that around 94% of AI adopters are planning to use container. The reason being, if you look at the portability, which is like, consists of around 10.4. But more than that, if you see here, the faster time to deployment, and you will see in the demo itself, like how easy it is to go ahead and deploy the containerized solution altogether. And when I say container and containerized solution, today container supports GPU. So even you can use a Docker Compose file to go ahead and leverage the GPU itself, right? And the easier management, resiliency, developer productivity, I think these are the obvious reason Docker is popular for. But the whole idea is, when you build a solution on AI, do keep in mind that for a testing purpose, and even in the production environment, when you have a sufficient resources, you can still use solutions like Kubeflow or solution like Docker containers to run your AI workloads. Now, to give you a glimpse around it, so this is how the Docker Compose file look like. There are a bunch of services like init, capture, and server. So init is something which it's basically a service which initializes the Redis with Redis AI model, and that is where you see a kind of a Python script which runs as a service. And then capture is one which service which captures the video stream frames from a webcam. So if you have a kind of a Raspberry Pi which is connected to the camera module, you can fetch the frames from that. And we have a web server service which basically serves a rendered image composed of the raw frame and the model detection. So with Docker, you can abstract a lot of things here, and it is just a Docker Compose file which I'm going to show you in the demo. Apart from that, if one other thing which recently has been introduced is Redis has we have a Redis data source for Grafana, which means that when you have a Grafana up and running, you can go ahead and search for Redis data source, and you can connect to the Redis database and fetch all this information which you required. So it is more like a kind of a monitoring tool for Redis itself. Um, so this is how you go ahead and install. Basically, Grafana is a service, and you pass on the environmental variables thing like install plugins, Redis app, and then it should be able to go ahead and use that particular data source. If you want to really use it with the GPUs, and then most probably wherever you specify the init.py, you just have to go ahead and say hyphen device, and your Docker Compose or the microservices will pick it up. Okay, so let's go to the demo part here. So let me show you. Let me open the terminal here. Okay, so this is a short demo where I'm going to show you the whole, especially the Redis Edge operation pipeline. So under the Collabnix, you have Redis AI Edge Analytics GitHub repo where I have put all the code. I have cloned the repository at this point of time. Under this, you will see that we have a Docker Compose file. If you want to look the same Docker Compose file which I have pasted on the slide, we have 3 of the services. Redis Edge is basically Redis plus all those AI stream time series and gears modules embedded into it. We have services like capture, server, and init. Prometheus here is optional, but if you are using Redis time series, then you don't need that because already we have Redis data source for Grafana, which is available. But I'm just showing an example the way we won't be using Prometheus here, but you can still go ahead and specify that service. For Grafana, with Grafana 7.0, this is a particular support which has come where it integrates it with the Redis data source. So let's go ahead and try to see the Docker. So I'm using my Mac machine, which has very latest beta version of 2010. Which is, again, it is not a GA, but at the same time you can still use the Edge release. So let's go ahead and build this particular Redis Edge components all together. You can see here that it is trying to bring up all the services most probably, and then this particular service gets started. It is loading basically the Grafana. If you see here, the installed Redis app successfully, which means that your Redis data source has been loaded. It will take some time till the Grafana comes up, but most probably it should be up by now. Let me refresh it. Okay, so you see a Grafana dashboard here. By default, you have, like, just for a demo purpose, I will go ahead and put it as supply as the username and password here. And most probably the Grafana should be up by now. At this point of time, I can go ahead and skip it. So once you go to the dashboard, you will see that video stream analysis. So this is an MP4 file which I have loaded, and it is there is a camera 0 here. So at this point of time, it is a file which I have loaded. That's why it is displaying. But when you have a multiple cameras, you can always go ahead and get it displayed here. On the right hand side, if you see the people count and the total unique, non-unique, right? So those are the things. Since there is one person who is making a video, and there is person, if you see one unique person who has been walking, so that is the reason why you see people count as one, whereas in other non-unique one you see a couple of them. One of the other thing which you can do is you can also look at, if you are really familiar with the Grafana, you can select a time frame and all. Let us look at, I was talking about the Redis data source support from Grafana. So let us search for Redis here. If you go to the add data source and try to search for Redis, you will see here data source which appears here. You can go ahead and try to select this. One other thing which you really need to do is you need to go ahead and even before you can import it, but even before that you have to supply the address here. So let me do it again. I will go to the Redis and then try to find out, try to supply the IP address here. So IP address, if you are running on your Mac machine, that should be, you should provide that, or local host. So this is IP address. Let me go ahead and verify that, opening a new window here. So the IP address is 192.168.1.4. It looks good. And then say save and test. So it identified those data sources. And then by now on the dashboard, you will see the Redis streaming as well as the Redis to appear here. When I click on Redis, it fetches all this information which you require, right? Ops per second, connected clients, network, memory, what is the memory it is consuming here. And then I have very limited resources through Docker Desktop, which I have assigned to it. So we really don't have to worry about it. But if you see here, this is Redis time series stream, which is coming in xat camera 0. So I can go ahead and also see like what kind of data or the streams are coming in. And this is ops per second in another way, where I can go ahead and select the timeline and it will show me especially the Redis version, as well as I can even go ahead and run the commands. Let me show you that. So we have introduced a kind of a new data source, and this is completely open source and especially free, Redis app. And with this, this is basically a new version of Redis data source which I introduced, where we have a CLI version which is available. Now let me show you. Think of it as like, okay, if I want to run a kind of a CLI and want to get a time series data for a particular timestamp, so let me first install it. So we have a Redis application here, which is plugin for Grafana, where I can build a custom panels altogether, right? So in the future, you might be able to see more and more modules appearing here. Even we could have a plan of using Redis AI or Redis Gears altogether. And if you go to the Redis data source, select this new one, and again, you provide especially the IP address of the Redis database server. So most probably it should be able to get connected, and I should be able to fetch the information. If you see here, the Redis CLI appear here, and the same information which you see. But let's go ahead and try to run some kind of a query right on top of your Grafana dashboard. So this is where you can run the command. So let me go back, and you can run all those. You can see the information about the modules, or especially the database. So this is a Redis server information which you are fetching it. So let me go back and try to fetch a time series kind of a data, right? So okay, let us see if it fetches the info of the module. So info modules will help you in understanding about what are the modules which have been compiled here. So since it has been containerized solution, so it might be something I really need to go ahead and verify this, why it is not displaying. But most probably you should be able to see the help window. Say, think of it as like a Redis time series. I have all these commands which I can go ahead and run it, like ts.create, ts.info. So it gives you all the information. ts.info expect especially the timestamp info. So let us go back to video streaming and try to fetch the timestamp altogether. So let me pick up the right one. Let's go to the video stream, and the streaming is going on. At the same time, I can go to the overview, and then let us pick up the camera 0, especially the timestamp. Since Redis is a time key value pair database, so key value database, so I can pick up any of the entries. So let me find out one at this point of time. So let's wait for some time. If I have some kind of a time stamp information here, let me open the view. Okay, let's pick up camera colon 0, something similar to that. Okay, let me inspect that. Maybe this is the way where we can go ahead and get some kind of data. No, not here. So the whole idea is what we are trying to do is running a query, right? So let me pick up this camera 0 and IFPS in FPS. So, and let me go ahead and put it in CLI and try to query it. So it will fetch me the value for that particular timestamp. Okay, let's put it here. ts.info and then the key, and it fetches the value here. What do you see here? Right, for particular timestamp, it fetches the value. Now this looks good. Okay, so, and I think I'm done with this presentation. I don't know whether we have time, but yes, definitely these are the references which you can go through. You can see this code and Docker Compose file on Redis AI Edge Analytics, especially. There are few of the links which you can, if you are really interested in Redis AI and in contributing for this project, you can visit this, and especially about the modules. You can find it under redislabs.com/modules. And these are the open source, software. So you can go ahead, contribute if you are, among the DevOps or the MLOps engineer. So I think I am done. Thank you so much.